Most problems we face right now can be solved quite literally at our fingertips. Need a ride? A place to live? A laundry service? Or groceries? The sharing economy allows us to rent all of these and more from each other. It is convenience to us as customers, but as suppliers of goods and services, we are treated not as employees but as contractors. In the case we are treated or paid unfairly, what can we do? Without a large-scale coordination with our peers, our individual actions wouldn't matter. What is essential, then, is a platform for us to organize a movement, or rather, a virtual union. A virtual union is a relatively new concept explored by the growing independently contracted working class. Organized online, the union fights for workers' rights, and should the need arises, plan a strike. Introducing StrikeSim. 6 industrial engineering and operations research students have come together to form StrikeSim, born out of a passion for social justice and technology, as well as a deep interest in simulation modeling. We are Andrea Kwan, Courtney Chow, Cynthia Wu, Elle Wang, Michelle Blight, and Nanavati Low. StrikeSim can answer 2 key questions when organizing a virtual union. What percentage of drivers would need to go on strike to be effective? How long should a strike be and when? Based on answers from these 2 questions, we can provide the profit implications of the resulting strike. StrikeSim assists unionized drivers to make the optimal decision if they do decide to strike, and also helps ride-sharing companies roll out cost-efficient strategies to mitigate bottom-line revenue impact in the event of a strike, as well as create contingency plans. All this and more can be done with a simple user interface. You can customize the simulation to your situation by entering the amount of drivers in the area, planned strike start time, percentage of drivers estimated to strike, and planned end time. After inputting the required information, click Simulate, and the system will import your results within several minutes. StrikeSim will output 3 graphs to help you understand what the implications are for the strike you just planned, specifically regarding servers overtime, cash overtime, and queue overtime. The company's reputation for being an on-demand service is heavily affected by customer service time, which is defined in our software as the time the customer requests the ride until the driver drops off the passenger at their destination. The first graph of queue overtime demonstrates the dramatic increase in the customer queue as soon as the strike occurs due to the loss of drivers on strike. You can then start to see the queue decreasing during the strike as the customers arrive at a slower rate and leave due to the loss of available drivers. The second graph shows the number of available drivers over time. Before the strike, number of drivers are assumed to be constant over time. When a strike occurs, a percentage of drivers suddenly becomes unavailable to serve customers, represented in the huge dip in the graph. You can minimize or maximize this dip by experimenting with the percentage of drivers you choose to be on strike. The last graphical output shows how your theoretical strike affects the company revenue. To be the most effective, you will need to choose the situation in which the company's revenue is the lowest. This graph will help you choose when and for how long you should strike for. In order to assess the best time interval to strike, you should pick scenarios you want to simulate. We recommend picking time intervals when demand distribution is high, for example, the morning rush hour. Then, from these scenarios, you can sort them into durations. For example, group all of the 1-hour intervals into one graph, 2-hour time intervals into another graph, etc. From there, you can figure out the optimal percentage of servers to be on strike by varying this field. Finally, as mentioned previously, choose the strike interval time that would produce the smallest revenue for the company. Interested in knowing how we do it? StrikeSim was originally built on Sigma, where we model a normal 24-hour day of business until a strike occurs. For the demo, we used data taken from the New York City government on taxi arrival and service times to bring you the most realistic model available commercially. When using StrikeSim, there are a couple things to keep in mind. 1. Right now, our model does not include the scenario where customers leave the queue when the waiting time is too long. We simply slowed down the arrival rate, which is realistic, but doesn't take into account ride cancellations. 2. Testing the model with different arrival and service time distributions. Although the New York taxi data is an invaluable resource and the most complete dataset we are able to obtain, we recognize that you might be using the simulator from anywhere in the world, and hopefully by the next update we will be able to include more parameters to provide accurate simulations wherever you are. 3. We would like to include an option for changing the minimum number of drivers who will not go on strike. The ride-sharing company can, for example, partner with other organizations to ensure that service can be met in case a strike does happen. Thank you. If you have any questions, please shoot us an email.